Okay, guys. Good evening, all of you. So, I think we were discussing types of defects, right? The topic going on was a type of defects. Okay, and till now, I think we have discussed in details about the stoichiometric defect. Right? Okay, so today topic is going to be a non-stoichiometric defect. By the way, yes, what is a non-stoichiometric defect? क्या था non-stoichiometric defect? Yes.
In spite of the defect, the ratio of the particles will not be same.
Yes. Because of the defect, the ratio of the species will not be same as that in an ideal crystalline. Okay, so either the ratio will be less or it can be more. Okay, so let us try to understand. Okay. So I'm just giving you one example of an ionic crystal, say NaCl. Fine, it's an ionic crystal, say zinc oxide. Now, both the NaCl which is the cation and which is the anion? Obviously, anyone can answer this. Sodium is the cation, chloride is the anion. यहाँ पर zinc is the cation, oxide is the anion. So यहाँ पर जो cation है, cationic part is outio sodium ion, which is an alkali metal, and zinc oxide में zinc is a cation again, which is a transition metal. Zinc तो metal है. So cations are mostly composed of metals. इतना जान लो. Cations are made up of what? Metals. Cations are made up of metals. Right? Got it? Cations are normally made up of metals. So non-stoichiometric defect में क्या हो सकता है? Number one, there can be a metal excess defect. Right? Metal excess defect मतलब now which ion is in excess? Metal excess मतलब कौन सा ion excess में होगा? आप बोलो. Cation. So excess cation. So metal excess defect means they can be here excess
So
cations. Okay. Yes, tell me.
So actually heading है.
Non-stoichiometric defect, okay, are of two types. Non-stoichiometric defect are of two types. एक है तुम्हारा metal excess defect. Metal excess defect means the cations are in excess. Okay, cations are in excess. ठीक है, लिख लिया?
Yes, sir.
Yes.
Yes, sir.
Okay, now how can the metal excess defect? How can there be a metal excess defect? Okay, so again, metal excess defect are of two types. Metal excess defect are of two types. Okay, so number one is it may be due to your extra cations occupying your interstitial sites. Excess cations occupying the interstitial sites. Okay, now just let me explain this. Fine. So again, I have been repeatedly telling you diagrammatically questions might come in. Okay, now say. So let me just try to explain this diagrammatically. Okay. So I'm just drawing this diagram. So suppose I have A positive ions out here, I have A positive ions out here, I have A positive ions out here, I have A positive ions out here. Okay, so now I'll place B negative ions out here. So which crystal am I drawing in? Is there any defect in this crystal? Do you see any defect in this crystal? No,
No,
this is
sir.
a perfect crystal. This is a ideal crystal, I suppose. It's ideal crystal. Now suppose if there is a cation occupying the interstitial position, if there is a cation occupying the interstitial position. Now, is the ratio same as that in an ideal crystal? पहले ratio क्या था? 1:1 था before. Now the number of cation excess में है. So this is an example of a non-stoichiometric defect because the ratio is no longer same as that in ideal crystal. And यहाँ पर कौन सा ion excess में? कौन सा ion excess में? Cations. And cations are normally metals. So इसको बोलते हैं metal excess defect. This is a metal excess defect. What kind of metal excess defect? Due to extra cations occupying the interstitial sites, right? Metal excess defect due to extra cations occupying the interstitial sites. Now, do you think this crystal will be electrically neutral? Do you think this crystal will be electrically neutral? Of course no, क्योंकि एक positive charge ज़्यादा है. So how will it become electrically neutral? Now again, in order to maintain the electrical neutrality, an electron will be occupying the adjacent interstitial position like this. एक कैटायन एक्स्ट्रा है तो एक उसको न्यूट्रलाइज करने के लिए एक इलेक्ट्रॉन, और दो कैटायन है तो दो इलेक्ट्रॉन, तीन कैटायन है तो तीन इलेक्ट्रॉन. Okay, so this is an example of a metal excess defect due to extra cations occupying the interstitial position. So number one चीज यहाँ पर क्या याद कर लेना है? So this is shown by crystals which shows number one Frankel defect, because as in Frankel defect the cations are occupying the interstitial position. So number one thing to be noted is that it is shown by crystals which shows Frankel defect. Which shows Frankel. Okay, so to work a figure dekha is the above figure illustrate which type of defect? Stoichiometric? No. Non-stoichiometric. कौन सा non-stoichiometric? Metal excess defect. Metal excess defect how? Due to extra cations occupying the interstitial position. And due to extra cations occupying the interstitial position. Okay.
Yes, sir.
Okay. For example, these are really important. These are important. Example. So ये जो zinc oxide है solid, it is white when cold. When it is cold, it is white. Okay. So on heating, when it is heated, क्या होगा? It loses oxygen irreversibly. It gets converted into zinc dipositive, and in the process, half O2 is released. Okay, and दो positive charge मतलब तुम्हारा यहाँ पर दो electron release हो रहा है. So it ionizes in this way on heating. Okay, so the zinc ions formed, they on heating they lose oxygen reversibly. Okay, so we can just add this out here. On heating, zinc oxide, it loses oxygen reversibly. Okay, then just write down the zinc ions formed. The zinc dipositive ions formed, what do? They occupy the vacant. They occupied the vacant, and this vacant interstitial position. Vacant voids in the crystal. Voids in the crystal. The zinc ions formed. Okay, ये जो zinc ion form होगा. Okay, so they will occupy this voids. Okay, the released electron gets trapped in the neighborhood and absorbs visible light. So यहाँ पर जो electron release हो रहा है, the released electron gets trapped in the voids. What do? Which absorbs visible light. Which absorbs visible light. Okay. As a result of which zinc oxide turns yellow in color. Okay, so this is a perfect example of this type of defect. So when zinc oxide is heated, it loses oxygen reversibly, and ये जो zinc ions release हो रहा है, okay, it will come into the vacant spaces, and the electrons which are released will also be trapped in the voids, and these electrons are going to absorb radiation, and if it absorbs radiation, obviously it will exhibit some characteristic color. Okay, so this is a perfect example of a non-stoichiometric defect. अब तुम लोगों को मतलब if I just draw the diagram, instead of A you can add on Zn dye positive, O dye negative, Zn dye positive. ठीक है, और heating क्या होगा, ये zinc ions यहाँ पर it will occupy the interstitial position like this. And electron trapped होने की वजह से this will absorb light. ये जब light absorb करेगा क्या होगा, it will get excited. So if it loses energy, that energy, if it falls in the visible region, it appears to be colored. I hope this is understood. Okay, so one type of non-stoichiometric defect is due to extra cations occupying the interstitial positioning. Okay, number one. And this question is very important.
Sir, what is that the zinc ions formed?
The zinc ions formed occupies the vacant voids in the crystal. The released electron gets trapped in the voids which absorbs visible light, and since they absorb visible light, they appear colored. As a result of which they appear colored. Okay.
Also.
So this is one type of metal exchange defect due to extra cations. Right?
Yes, sir. Sir, means like before the reaction, the ZNO was white in color, and then after the reaction,
after heating, this change occurs. Okay, after this heated, this change occurs, and
yes,
due to trapped electron, it becomes yellow in color.
Yes,
so
sir.
तुम लोगों का लैब में ना, अब तो स्कूल तो बंद है, जब तुम लोग करोगे लैब में टेस्ट, जिंक ऑक्साइड को एक ट्यूब में लो, इट्स व्हाइट इन कलर, जैसे तुम थोड़ा सा हीट करोगे ट्यूब को, इट टर्न्स येलो इन कलर, ब्यूटीफुल कलर चेंज. ओके
Yes, sir.
ओके, ये हुआ, दिस इज वन वे वेयर metal can be in excess. One way of metal excess defect. Okay, now what is the second way? अब देखो, देखो ध्यान से देखो. Okay, ये देखो, what have I erased out here? What have I erased?
Anion.
Anion. So which ion is in excess?
Cation.
Cation. So can I write again metal excess defect out here?
Yes, sir.
But due to what? What is the reason? Due to
Excess of
due to, I can write down anionic vacancies. Due to anionic vacancies. So ये भी metal excess defect है, but one anion is missing due to anionic vacancies. Okay. So this is the, if the anion position occupied by anion are missing, these are holes भी बोलते हैं, square areas. ठीक है, vacant position. Now, is this crystal electrically neutral?
Electrically neutral? No, sir.
No. So, in order to assume electrical neutrality, again, an electron will be trapped out here. Right? Electron will be trapped out here. And these centers, these holes where electrons are trapped are known as here F centers. Right? They are known as the F centers. Okay, the electrons trapped in anionic vacancies are called F centers. Right? So what are F centers? What are F centers? The electrons trapped. कहाँ पर trap हुआ electrons? The electrons trapped in anionic vacancies are called F centers. Right? And remember, these F centers are responsible for the color of the crystals. Right? Okay, they are responsible for the colors of the crystal. ठीक है, so यहाँ पर भी metal excess defect हो रहा है, लेकिन due to F centers है, due to F centers है. Okay, so now I'm going to show you one example. ठीक है, I'm going to show you one example. So देखो, NCERT में ये चीज को details में discuss नहीं किया है. Okay, so let us see. ग्रामेटिकली पहचान है, हम लोग को ये डायग्राम देगा. अब तुम लोग देखोगे, डायग्राम देखने से एक कैटायन एक्सेस में है. कैटायन क्यों एक्सेस में? बिकॉज वन एनायन इज मिसिंग. सो मेटल एक्सेस डिफरेंट ड्यू टू एनायनिक वैकेंसीज. बस. ओके, नाउ NaCl crystal, again it is colorless, but when we heat NaCl crystal in sodium vapor, right? On heating NaCl crystal in sodium vapor, on NaCl crystal in sodium vapor, it assumes yellow color. है. कलर क्या होगा? NaCl का कलर क्या होगा? गोल्डन येलो है. ओके, मतलब NaCl ऐसा हीट करने से गोल्डन येलो नहीं होगा. नहीं तो सब्जी बनाते हो NaCl तो हीट होता है. All the vegetables will turn golden yellow. But no, when NaCl is heated in sodium vapors, right? When NaCl is heated in sodium vapors. Okay. Now, why does this happen? Let me just explain you. Listen carefully. If not understood, please let me know. So, we have crystal of NaCl like this. So, NaCl to an ideal crystal. Suppose we draw an ideal crystal out here. So, there is a NaCl crystal. फाइन, ये एक NaCl क्रिस्टल है सपोज. Okay, now we are heating in sodium vapor. Sodium is in the vapor state. But sodium vapor state, it is in high, it has very high energy, and we know this sodium, it has a high tendency to ionize and release an electron like this. Sodium vapor, sodium
So,
solid.
not on this board.
All of you are having this problem. सबको ब्लॉडी दिखाई दे रहा है? Okay, so what happens? NaCl तो NaCl gaseous state it's in a very high energy. It's converted into the vapor state. तो ज़्यादा energy, so it will ionize itself. Now what will happen after ionization? Listening, the chloride ions will diffuse into the surface like this. यहाँ पर chloride ion है, so it will diffuse from the surface. The chloride ion will leave this and diffuse from the surface like this to combine with sodium ion out. To combine with sodium ion. So यहाँ पर तो एक anionic vacancy create हो रहा है. यहाँ पर तो एक anionic vacancy create हो रहा है, and these anionic vacancies will be occupied by the electrons which are released. Actually, this is a mechanism. It is how electrons are trapped. Right? This is how electrons are trapped. But questions won't come from it. Don't worry. I'm just explaining it. So क्या होगा? NaCl था पहले. In the vapor state, sodium ionizes to give you sodium ion and electron. The chloride ion will diffuse from the surface to combine with sodium ion like this. It will diffuse from the surface to combine with sodium ion, thereby creating an anionic vacancy. These anionic vacancies will be further occupied by the electrons. It will be occupied by the electrons, giving rise to what? Giving rise to your F centers like this. And these F centers, again, I'm repeating this, F centers are responsible for the color. Okay. So, question आ सकता है, why NaCl crystal appears golden yellow on heating in sodium vapors? So, क्या होगा? Color का question आएगा तो एक ही आंसर होगा. This is due to the presence of what? F centers. Right? So, on heating NaCl appears yellow or golden yellow. Okay, on heating LiCl crystal को heat करोगे, it appears again what? It appears to be pink. Okay, so again reason, yes. Reason क्या होगा? So this
Due
is
to the presence of
this
F
is
centers.
due to the presence of, this is due to the presence of what? F centers. This is due to the presence of F centers. Okay. So F centers में क्या होता है? F centers में what are present? क्या होता है? Protons, neutrons, electrons. What are present in F centers? F centers मतलब the anionic sites which are occupied by what? The anionic sites which are occupied by electrons. Okay. So just write down. These electrons absorb energy. The electrons trapped in F centers, okay, they absorb energy. The electrons trapped in F centers absorbs energy from the white light, from the visible light. Okay, so the electrons trapped in F centers, these electrons which are trapped, they will absorb light from the visible. They will absorb energy from the visible light. Okay. For excitation, but the electrons will get excited. They will absorb energy, which makes the crystal color. Which makes the crystal color. Which makes the crystal color. Okay. So देखो, non-stoichiometric में एक तो बोला मैंने metal can be in excess. cation can be in excess. दो तरीके से, एक cations are occupying the interstitial position, ठीक है. Number two, cations कैसे excess हो सकता है? When some anions are missing from the lattice due to anionic vacancies. And जब anions are missing, to balance the charges, electrons will occupy its position, and the positions which are occupied by electrons are known as the F centers. And these F centers are responsible for the color. And these F centers are responsible for the color. Okay. So any problem till here? Is it understood? Is it understood? Okay. अब मैंने बोला देखो एक मेटल एक्सेस में हो सकता है. नंबर 2 स्टोइशियोमेट्रिक डिफेक्ट क्या हो सकता है? बोलो व्हाट इज द नंबर 2 स्टोइशियोमेट्रिक डिफेक्ट? एक तो मैंने बता दिया मेटल कैन बी इन एक्सेस. मेटल एक्सेस में हो सकता है. There are two ways in which metal can be in excess. So what is the other type of non-stoichiometric defect then?
Non-metal excess.
So metal एक excess भी हो सकता है, metal कम भी हो सकता है. So number 2 type of metal non-stoichiometric defect, number 2 type is here metal deficiency defect. चलो metal deficiency defect. Now क्या होगा? The metal or the cations can be in lesser amount. Okay. So let us see again what are the two ways of metal deficiency defect. So can I run this?
Sir.
Sir,
What go up?
your video off गयो. Hi.
Okay. So now, I'm just erasing this thing. So metal excess defect पड़ा, एक हो सकता है metal deficiency defect. Okay. So metal deficiency मतलब cations can be present in lesser amount. So what are the two ways of metal deficiency defect? Let us now just try. मतलब देखो यहाँ से most common question तुम लोग को diagrammatically पूछेगा. Diagrammatically questions might come in. Okay. So one type of metal deficiency defect is due to cation missing from the lattice side. So number 1 metal deficiency defect is due to cations missing from the lattice sides. Okay. Okay, so let me just draw it. Please try to follow the diagram. Okay. So again, let me draw it.
Yes, sir.
You can draw along with me if you want to, or you can take a screenshot and draw later on. Your wish. So, okay, so first let me draw an ideal crystal. पहले मैं ideal crystal बना लेता हूँ. So, क्या बना लिया मैंने? So which crystal is this, guys?
Ideal crystal.
Okay. अब देखो. Just have a look at. No need to do anything. क्या हो रहा है? What is happening out here?
cation is decreased.
One cation is missing from
Yes,
its
sir.
lattice sites. Cation is missing from its lattice sites. Yes.
Yes, sir.
Which ion is in lesser amount, the cation or anion? Both
Cation.
ions are missing.
Cation.
Cation. So this is a metal deficiency defect. Why? Due to cations missing from the lattice sites. Cations are missing from the lattice site. So it's a metal deficiency defect. Simple SI diagram. 100% this type of questions are going to go. Metal deficiency defect due to cations missing. Now, tell me one thing. Are the charges balanced?
No, sir.
No, the charges are not balanced. So the charges can be balanced only if the cations from the nearby position acquires double the charge like this. If the cation from the nearby position acquires +2 charge, I think the total positive charge will be 2, 3, 4, 5, 6. Total negative charge will be 6. Okay. So ये जो type of defect है, in this type of defect, okay, the nearby metal ion acquires 2 charges instead of 1. So यहाँ पर क्या होगा in this type of defect, the nearby cations should acquire or must acquire +2 charge instead of 1. मतलब, what is the conclusion we can draw? These type of defects are exhibited by those cations which can exhibit variable oxidation state. Okay, so this type of defect we can write out here. So these kind of defect are exhibited by metals which can exhibit a variable oxidation state. मतलब यहाँ पर जैसे the cation, it must have the potential to exist in +1 charge and it can also have the potential to exhibit +2 charges. Right? So only if the metals can exist in 2 different oxidation states, it will exhibit this type of defect. Right? Only if the metal can exist in 2 oxidation states, it will exhibit this type of defect. For example, both are examples. Say iron, it can have an oxidation state of +2. It can have an oxidation state of +3 as well. Right? So this type of defect is exhibited by those ions, those cations, okay, or those metals which can exhibit variable oxidation state. So variable क्यों? जैसे इसका भी +1 चार्ज होने से तो ये इलेक्ट्रिकली न्यूट्रल नहीं रहेगा ना, एक एनायन ज्यादा हो रहा है. So to balance the positive and negative charges, the cations from the nearby position will have to acquire +2 charge. Meaning these defects are exhibited by only those crystals which can exhibit variable oxidation state. Okay, जैसे if the cation is sodium, will it exhibit this type of defect? No, sodium का तो क्या variable? Sodium exhibits only one oxidation state of +1. Sodium never shows +2. So ये type of defect दिखाने के लिए the metal must exist in 2 different oxidation states. Fine?
So
Yes, tell me.
what give more examples, of this kind of metals?
Iron is an example. Iron is an example. Nickel is an example. Okay, mostly iron, nickel can exist in nickel dipositive. Nickel can have tetrapositive. There are many. Okay, so most good example would be iron. Right? Fine.
Yes.
Yes, sir.
So ये हुआ तुम्हारा मेटल डेफिशिएंसी डिफेक्ट. यहाँ पर हुआ तुम्हारा मेटल डेफिशिएंसी डिफेक्ट. ओके, अब how can the metal deficiency defect arise again? So you have written this. Don't worry about the letters I'm telling you. Trust me. डायग्राम देगा तो तुम लोगों को आइडेंटिफाई करना है। और ये सब थोड़ा थोड़ा पॉइंट जो मेन पॉइंट है वो लिख लो। ओके, नाउ मेटल डेफिशिएंसी डिफेक्ट, हाउ कैन इट ऑकर? व्हाट इज द सेकंड वे? सो मैं डायग्राम में दूंगा, तुम लोग खुद बताओगे ना। ओके,
Yes, sir.
ओके, फाइन। अच्छा, बोल क्या डिफेक्ट है यहाँ पर? विच टाइप ऑफ डिफेक्ट? कौन सा आयन ज्यादा है, कौन सा आयन कम है?
Excess of anion.
But due to excess anion means metal ions are in deficiency now. Excess anion मतलब
yes,
metal
sir.
ions कम है, so ये metal
Cation
deficiency
का
defect due to
deficiency of cation.
excess anions, due to excess anions occupying the interstitial position. Due to excess anions occupying the interstitial position है भाई। एंड ऑल्सो यहाँ तो एक नेगेटिव चार्ज ज्यादा है, तो चार्ज बैलेंस करने के लिए फिर वही होगा +2 नियर बाई कैटायंस को, इट शुड ऑक्वायर अ डबल द चार्ज है। ठीक है, सो ये दिस टाइप ऑफ क्वेश्चंस में तुम दिख रहा है यहाँ पर मेटल डेफिशिएंसी हो रहा है, क्यों हो रहा है? ड्यू टू एक्सेस एनायंस ऑक्युपाइंग द इंटरस्टिशियल पोजीशन, एंड चार्जेस बैलेंस करने के लिए ये एक कैटायन को डबल द चार्ज ऑक्वायर। ठीक है,
Yes, sir.
ओके, नाउ देखो, so I'll drop all this. I'm dropping this, right? Okay, I'm dropping all of this, and now we have a numerical on this part. एक numerical भी है, okay, and numericals are quite important. Okay, now so there are some types of oxides which are known as your mixed oxide. Mixed oxide, okay, mixed oxide means the mixed oxide means the metals are in different oxidation state.
Go, sir.
Go. Hayo.
Okay, for example, Fe3O4. Just listen, just listen. I just wanted to explain you. So Fe3O example is an example of a mixed oxide. यहाँ पर actually दो oxides, Fe2O3 and Fe. Okay, it's a mixed oxide. Fe3O4, it's a mixed oxide. Right? So now, what is the oxidation state of oxygen? Always, what is the oxidation state of oxygen?
-2.
-2 है तो आयरन का, ये आयरन का कितना होना चाहिए? +2.
+2.
एंड 3 ऑक्सीजन का -6, 3 ऑक्सीजन का -6, 2 आयरन का +6, 1 आयरन का +3 है। समझ में आया? 1 ऑक्सीजन का -2, 1 आयरन का +2, 3 ऑक्सीजन का -6, तो 2 आयरन का +6, 2 का +6, 1 का +3. So iron is in different oxidation state. Iron is in different oxidation state. So yes, there are ample examples of mixed oxide where a metal is in two different oxidation state, where the metal is in different oxidation state. Okay, fine. I just wanted to explain it. So it is possible in an oxide there can be two metals with different oxidation number. Right? I'm rubbing this. Okay, I just wanted to explain the thing. It's not related to this topic. Okay, write down one question. Write down one question. It's from the NCERT, of course. NCERT related question. Okay, so write it down. Analysis. Analysis. Just so little analysis shows that analysis shows that analysis shows that a nickel oxide has the formula nickel 0.98 चलो copy the question. So please don't leave. ये leave करने से फिर ये question भी leave हो जाएगा तुम लोग. Okay, so analysis shows that nickel oxide has the formula nickel 0.98, oxygen 1. What fraction of nickel? Okay ना, ये जो formula है ना, ये it is depicting what type of defect, कौन सा defect हो रहा है यहाँ पर, ये according to this formula. What type of defect do we see? देखो तो, what type of defect do we see?
Metal excess defect.
मेटल एक्सेस का है
ये
मेटल तो कम है
metal
as compared to
deficient
anion. Metal
0.9
तो
right
for 1 anion there is only 0.98 nickel है. ये तो मेटल डेफिशिएंसी डिफेक्ट है.
metal
ये तो
deficiency
मेटल डेफिशिएंसी है, मेटल आयन कम है. So we have to predict the fraction of nickel dipositive and nickel. So just listen, तुम लोगों का काम है देखना. So we don't know the number of nickel dipositive. So let us suppose that let the number of nickel dipositive ion be equal to x. ये assume कर लेते हैं. ठीक है, let the number of nickel dipositive ion be x. So therefore, what is the number of nickel tripositive ions, guys? Then कितना होगा ये? What is the total number of nickel? Total number of nickel कितना है according to the formula? As per the formula, how many nickel atoms are present? Total, how many nickel are there as per the formula? How many nickel are there as per the formula? 0.98. So out of 0.98, nickel dipositive ions का amount x है. So what is the number of nickel tripositive ions? It will be 0.98 minus x. Fine. Out of total 0.98, dipositive x है तो remaining will be tri. अब देखो 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 यहाँ पर देखो भाई. So zinc oxide में what is the magnitude of positive charge? What is the magnitude of positive charge out here? What is the charge of zinc? Plus two. Just have a look out here. Oxygen का कितना है? -2. So the charges are opposite, but the magnitude are same. इसका भी 2 है, इस 2 है. The magnitude of the positive charge and the magnitude of the negative charge must always be same. Obviously, charges opposite होगा, but talk about the magnitude. The net magnitude of the positive charge and the net magnitude of the negative charge must be same. If it is a neutral है, ये भी neutral है, यहाँ पर तो कोई charge वार्ज नहीं दिखाई दे रहा है. So the magnitude of the positive and magnitude of the negative ion should be same. ठीक है? ना मैं ये लेके चलता हूँ. So what will be the total positive charge? What is the total positive charge? Total positive charge कितना होगा? बोल. देखो ये, what is the charge on one nickel dipositive ion? What is the positive charge on one nickel dipositive ion? एक nickel dipositive ion, what is the positive charge?
+2.
+2. So x nickel ions में what is the total positive charge? वन निकल डाइपॉजिटिव में तुम्हारा चार्जेस +2 है, तो x नंबर ऑफ निकल डाइपॉजिटिव में व्हाट इज द टोटल चार्ज? 2x एक निकल ट्राइपॉजिटिव में अगर चार्ज +3 है तो 0.98 माइनस x निकल ट्राइपॉजिटिव में हाउ मेनी पॉजिटिव चार्जेस विल बी देयर? कितना पॉजिटिव चार्ज होगा? एक निकल ट्राइपॉजिटिव में +3 है तो इक्वल कितना होगा? So 3 into 0.98 minus x. Now out here, what is the total negative charge, guys? Oxide, यहाँ पर ऑक्साइड का नेट चार्ज कितना है? What is the net magnitude of oxide ion? कितना होता है? ये तो पता होना चाहिए. It is equal to 2. ना ऑक्साइड मतलब चार्ज 2 होगा. I am just writing the magnitude. Magnitude इसका 2 है तो इसका भी 2 होना चाहिए. ठीक है? Now, so therefore I can write down the net positive charge 2x plus 0.98 minus x into 3. This should be equal to 2. The net positive charge should be equal to the net negative charge. Therefore, what is the value of x? निकाल. समझ में आ रहा है मैं क्या कर रहा हूँ? The total positive charge should be equal to the total negative charge, which is equal to 2 है, क्योंकि ऑक्साइड है नहीं, ऑक्साइड का 2 होता है. तो आप निकालो x का वैल्यू क्या होगा? What is the value of x? Solve करो. It's easy.
0.9.
Huh?
0.94.
0.94.
0.94. Good. 0.94. So what is the fraction now? What is the fraction of, or मैं fraction में भी कैलकुलेट कर सकता हूँ, परसेंटेज. चलो परसेंटेज ही कैलकुलेट करना था मैं. So what is the percentage of nickel dipositive ion? Okay, what is the number? 0.94. What was the total number of nickel? 0.98. Total number of nickel into 100 है. ठीक है? कितना आ रहा है कैलकुलेट करो. कितना परसेंटेज आ रहा है? 96. So number इतना आ रहा है. So what is the number of nickel tripositive ion? 0.98 minus 0.94. So this will be equal to 0.04. So percentage of nickel tripositive 0.04 divided by 0. Total was 98 into 100. कैलकुलेट करो, ये आना चाहिए 4% ही आना चाहिए. Now these type of problems, I'll rate this as very important, right? Especially in a boards level, this is very important. Is it understood, guys?
Yes, sir.
All of you? If I send one more problem like this, you can do it on your own now. चलो NCERT में there are enough problems. NCERT देखो और ये करो. ठीक है, कोई लाइन में अगर कुछ समझ में नहीं आ रहा है तो just let me know right now. कुछ समझ में नहीं आ रहा तो just let me know. ठीक है, तो can I proceed to the next one then?
Yes, sir.
I'll rub this.
Yes, sir.
Okay, fine. I'm rubbing this. I'm just erasing this. Okay, so देखो हम लोग ने मेटल एक्सेस डिफेक्ट पढ़ा, मेटल डेफिशिएंसी डिफेक्ट पढ़ा. So last type of non-stoichiometric defect is here impurity defect. Hey, again very important. Hey, so last type of defect will be a impurity impurity defect. Okay, so impurity defect means the defect which arises due to addition, okay, of foreign particles in a crystalline. So how does this impurity defect arise? So these impurity defect arises when some impurities are added to the crystalline. And ये जो process है ना impurity add करने का, the process of addition, the process of addition of foreign particles in a crystal, इसको क्या बोलते हैं हम लोग? इसको बोलते हैं हम लोग doping. So what is doping? The process of addition of foreign particles in a crystal, इसको बोलते हैं हम लोग doping है. Okay, the process of addition of foreign particles, species in a crystal is known as doping. अब ध्यान से सुनो ये. Okay, you need to understand this. Be attentive for a few minutes, then it will be over. Okay. Just. So all of you are having summer vacation, I suppose, na?
Yes, sir.
Okay, good. So now let me draw a sodium chloride crystal. We have sodium ion out here. I 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 have sodium ion out here. Right?
Yes, sir.
And say suppose I have chloride ion out here. So कौन सा crystal बना रहा हूँ?
Ideal, sir.
Ideal.
Good. Ideal crystal. Yes. इसमें कोई imperfections नहीं. Now, if I add strontium chloride, SrCl2, I'm doping with SrCl2. And normally the cations are doped क्योंकि cation छोटा होता है तो. So strontium chloride में we are adding strontium ion. Strontium का charge है +2. Okay, so if I add strontium ion, which ions will be replaced by strontium? Well, which ions are going to be replaced? I'm adding a cation. So obviously, कौन सा ion replace करेगा strontium?
Cation.
Cation, मतलब sodium ion. What is the net charge on strontium?
+2.
+2. So how many sodium ions will be replaced?
2.
2. So I can just write down for every strontium ion added, 2 sodium ions will be replaced. 2 sodium ion replace करेगा. 2 sodium ions will be replaced. क्यों 2 sodium ion? क्योंकि total charge तो इसका +2 है, तो 2 sodium का charge +2 होगा. So 2 sodium ions will be replaced. Okay, out of which one position will be occupied by strontium ion. देखो ये क्या हो रहा है? So actually 2 sodium ions are going to be replaced, ठीक? But strontium ion is going to occupy one of the position like this. एक position तो strontium occupy करेगा. Got it? 2 sodium ion missing है, लेकिन one of the position will be occupied by strontium. So how many cation vacancy are created? बोलो, एक strontium add करने से how many cation vacancy will be created? 1. So I can just conclude that for every strontium ion added, 1 cationic vacancy will be created. Got it? So एक strontium add करने से 2 sodium ion replace हो रहा है, but out of the 2 positions, 1 position तो strontium ion occupy करेगा. Okay, so देखा जाए तो यहाँ पर एक strontium add करने से खाली एक ही cationic vacancy create हो रहा है. Cationic vacancy मतलब the vacancy which is created by the cation position. जब cation का position में vacancy create होगा उसको cationic vacancy. Now, if I add 100 strontium ion, how many cationic vacancies will be created? एक strontium ion add करने से एक cationic vacancy. So, if I add 100 strontium, how many cationic vacancy? 100. If I add 1 mole of strontium, how many cationic vacancies will be created?
1 mole.
1 mole.
1 mole. 1 mole. 1 mole add करने से 1 mole. ठीक है? Fine. Okay, good.
Sir.
Now it's understood. So this type of defect which arises, this type of defect which arises due to addition of foreign materials. Right? So this type of defect which arises due to addition of foreign substances is known as an impurity defect. Right? So this is an example of impurity defect. Just diagrammatically ये दिखाई देगा तो कौन सा defect है? Impurity defect है. And ये आता है तुम्हारा non-stoichiometric में आता है क्योंकि the ratio of cations and anions are not same as that in ideal crystal. Ideal crystal में तो strontium था ही नहीं. Yes, only sodium and chloride ion आते हैं. So यहाँ पर तो defect की वजह से एक foreign substance आ रहा है. Obviously non-stoichiometric defect है. Okay, non-stoichiometric defect कैसे? ये impurity defect. Okay.
Excuse me,
now,
sir.
Yes, बोलो.
Sir, is it necessary to take strontium only every time, or can we take
कोई भी
other
जैसे तुम्हारा
also?
बेरियम, चलो बेरियम डाइपॉजिटिव दे दिया, बेरियम डाइपॉजिटिव दे दिया और मैग्नीशियम डाइपॉजिटिव दे दिया. आई एम जस्ट गिविंग एग्जांपल, बट मोस्टली सोडियम क्लोराइड को स्ट्रोंशियम से डोपिंग करते. ठीक है, तो एनी अदर आयंस माइट बी गिवन है. अब देखो ना, तुम्हारा यू आस्क मी अ वेरी गुड क्वेश्चन. नाउ यू आस्क मी अ वेरी गुड क्वेश्चन. नाउ इफ आई ऐड अ कैटायन हैविंग +3 चार्ज, देन क्या होगा कंडीशन? बोल. मैंने सपोज डोपिंग किया, सपोज
Three cations will be removed.
मैंने डोपिंग किया एक मेटल आयन का जिसका चार्ज +3 है. So how many cations will be replaced?
3 cations.
3 cations will be replaced. Out of 3, 1 will be occupied by cation.
Yes,
3
sir.
replace हो रहा है, 3 में से तो एक replace होगा. So ये करने से how many cation vacancies are created?
2.
So is the concept clear now?
Yes, sir.
Okay, fine. So it's a very nice question, but fine. चलो. Now this is the first thing
Yes,
which might
sir.
come. ये आ सकता है तुम लोगों को. So next thing is we have a numerical from this particular part. Okay, we have a numerical from this particular part. Okay, numerical भी आ सकता है. चलो एक numerical करते हैं. चल कॉपी कर, कॉपी इट quickly.
Sir, what did you write that 10 to the power 3 m e?
Mode of mole.
Hey, lala.
Okay, so let us try to solve this. Okay, fine. अच्छा, पहले हम लोग स्टेटमेंट समझते हैं. What is the statement? What is the statement? Hey, if NaCl is doped with 10 to the power minus 3 mole percentage of strontium. Percentage means out of
100.
So this means that it's doped with 10 to the power minus 3 mole percentage strontium chloride. This means that 100 moles of NaCl is doped with 100 moles of NaCl is doped with 10 to the power minus 3 mole of strontium chloride. इसका मतलब ये. Okay, this means that 100 more percentage, इसलिए मैंने 100 लिया. So 100 moles is doped with. So now tell me, 1 mole of NaCl is doped with how many moles?
10 to the power 3 by 100.
10 to the power minus 3 by 10 to the power 2. This is 10 to the power minus 5 mole of strontium chloride. Now, now 1 mole अगर तुम strontium chloride add करोगे, will create how many cationic vacancies? अभी तो हम लोग ने तुम लोग ने आंसर दिया था, एक strontium add करने से एक cationic vacancy. So 1 mole strontium chloride add करने से how many cationic vacancies?
1.
1 mole cationic vacancy. बराबर. So how many cationic vacancies per mole? यहाँ पर 1 mole में how many strontium chloride are added? 10 to the power minus 5 mole per 1 mole of NaCl. So 10 to the power minus 5 mole strontium chloride add करोगे तो how many cationic vacancies, guys?
10 to the
How
power
many?
minus
10 to the power minus 5 cationic mole. So 10 to the power minus 5 mole means what number? 1 mole मतलब 6.02 into 10 to the power 23. 1 mole मतलब 1 mole cationic vacancy मतलब इतना. 1 mole is just a number. Mole मतलब Avogadro number. 1 mole cationic vacancy बोले से कितना? तो 10 to the power minus 5 बोले से इतना. So कितना हो रहा है?
video guys, sir.
So battery is about to die. चलो, so battery is about to drain off. Battery is draining off. So देखो 1 मतलब 10 power minus 5 mole को मैं number में change करा. 1 mole मतलब आप अगर number 10 power minus 5 मतलब इतना. So what is the answer? 6.02 into 10 to the power 90 ना 90 ना. हाँ.
Yes, sir.
18 cationic vacancies. Okay, so these are two very important questions. Right? These are two very important questions for your boards level. Right? परसेंटेज में क्या था, मैंने पर मोल में निकाला पहले, क्योंकि कॉन्सेंट्रेशन निकालना है. कॉन्सेंट्रेशन मींस पर आउट ऑफ 1. सो 100 को डोप किया था 10 को -3, सो 1 मोल वाज डोप्ड विद इतना मोल. सो 10 को -4 स्ट्रोंशियम क्लोराइड ऐड करने से 10 को -4 कैटायनिक वैकेंसी क्रिएट होगा. बस इतना पता है मुझे. सो 10 को -5 मोल को मैंने नंबर में चेंज किया, जस्ट मल्टीप्लाई बाय एवोगाड्रो नंबर, मेरा नंबर में आया 6.02 into 10^18 cationic vacancy. Okay, are these things clear now? कर पाओगे?
ट्राई करेंगे.
Try करेंगे. Of course, I'm damn sure you are able to, you'll be able to do this. Okay, now देखो, I'll just